Right, so here's a wee example that we did in the class. Okay, so it's from 2013, question 8, part C, and it's worth, if you can see that there, it's worth 4 marks, and it's all about just calculating the size of a file. That's normally worth 3 marks itself, but what they're also asking is how many of these pictures can get fitted in a 12 gigabyte flash drive, so it's a wee bit more complex. Now, what you should be looking at is the key things, okay, so the resolution's mentioned. You've got the colour depth as well, so you've got resolution, colour depth, and the actual size of the image, and that's all you need to calculate the size of the image. Okay, so it's always useful just to even draw a wee representation. So we've got 4 inches by 6, okay, so 4 inches by 6 inches. Now, what we've got here, for every inch you go along, you're actually going past 1024 dots per inch pixels. So for every inch you're covering 1024 pixels. So what you're wanting to do with these, there's basically 3 rules that you have to do. We want to convert these into pixels. We then want to find the number of pixels, which is essentially calculating the area, and then we just want to times it by the colour depth. Okay, so we'll find the number of pixels first. So what we want to do is convert 6 inches into just the number of pixels along the way and the number of pixels down. So the number of pixels for its length, and we'll just call this one its height. So for its length, the number of pixels is that equals 6, and then you're just timesing it by 1024, because for each inch there's 1024, so for 6 inches it's just 6 times 1024, and that gives you 6 times 1024, and that is 6144. Okay, so that's the first part done. We want to calculate the height, and again we know it's 4 inches, and we know it's 1024 dots per inch, so it's 4 times 1024, and that gives you 4096. Okay, so this is in pixels, so the length is actually 6144 pixels and the height is 4096 pixels. Now to calculate the number of pixels, all we're going to do is essentially just calculate the area. Okay, so if we just say number of pixels, that equals length times height, and that equals 6144 times 4096. Now you'll eventually, the more you practice, you'll eventually take wee shortcuts and have all the calculations essentially in the one calculation. So that's 6144 times 4096, and this gives you the number of pixels altogether, as you'll see, quite a large number. Okay, now, so that's the number of pixels. Now, if you're not finished there, away in standard grades, or if you're just calculating a black and white picture, the number of pixels was the number of bits. However, we need to be using this number, so this is a colour depth. So for each pixel, we require 24 bits. So what we're actually having to do is to calculate the number of bits, it's times the number of pixels by the colour depth. So we say number of pixels times colour depth, so this is a wee bit back to run, equals number of bits. Right. So number of pixels is 25165824, and then we just times the colour depth, which is 24. So if I now times that number by 24, and we get, surprise surprise, an even bigger number. So that equals 0.639797776, and that's in bits. Okay, so this is answer in bits. Now that number's far too big, so we're going to have to try and reduce that number by changing the units. Okay, so we're going to make the units bigger and that number will come down. Okay, so I'll keep the wee calculator here. Now to get from bits to bytes, divide by 8. So we divide this number by 8 and that gives you it in bytes. Okay, now to get from bytes to kilobytes, we divide by 1024. And that gives you in kilobytes, sorry. Okay, still number's a bit too big and we can get it even reduced by dividing by 1024. And this gives you the size of the image is 72 megabytes. Okay, so that's the size of the image. That alone would get you your 3 marks, okay? And generally speaking, you get a wee mark for that, and a mark for your final answer. However, we've thrown you another wee mark, and this is just the how many pictures can you get into a 12 gigabyte flash card? So if we look at 72 megabytes per picture, so it'll be probably easier if we'd actually convert this into megabytes. Okay, so we can say 12 times 1024 gives you this number. Okay, so the actual cards they gave you in gigabytes, but we've now just converted it into megabytes. Okay, so we're converting it into the same unit, so it's easy enough to now make a calculation of how many of these pictures can fit in. Okay, so card in megabytes is that. So all we do is we just say number of photos equals the total size of the cards, and just divide it by 72. Now, divide by 72. Okay, again, I'll work out that this is 512 divided by 3, and this is 170.6. Now, you wouldn't leave your answer there because we're not going to be storing 0.6 of a picture. So what you'd want to do in this case is round it down. So we just say 170 pictures. Okay, and that's how you answer that question. So first thing you do is you make the measurements in pixels, which we did here. We then calculate the total number of pixels, which is essentially multiplying these together, gives you an area. We then, from the number of pixels, we can then calculate the number of bits because we times the number of pixels by the colour depth, which gives you a number of bits. We then get it into a sensible unit, and then the wee add-on was just to work out how many of these pictures can fit into a 12 gigabyte flash card.